Chapter 7, Exercise 7.68. Many computer chips are manufactured from silicon, which occurs in nature as silicon dioxide. Once heated to melting, it reacts with solid carbon to form liquid silicon and carbon monoxide. In industrial preparation of silicon, 172.5 kilograms of silicon dioxide is allowed to react with 101.8 kilogram of carbon to produce 75.0 kilogram of silicon. Determine the limiting reactant for the reaction. Before we do the calculation, my guess is this: silicon dioxide might be more expensive and therefore is the limiting reactant. Carbon is cheaper and very likely is going to be in excess. But now let's do the calculation for this problem. First, we need to write out the chemical equation and balance the chemical equation. I'm going to put my equation here. So you have silicon O2 plus C, and you get silicon plus CO. Of course, it's not balanced. We need to balance silicon first. It's good. Oxygen, put 2 here, and then 2 carbon on the right side, and then it's balanced. So 1 mole silicon oxide reacts with 2 mole carbons. I usually use a trick. I view this as a C2 molecule. Alright, so because if you have SiO2 reacting with C2, you still get the same products. The reason I view this as C2 is because we can have a 1-to-1 ratio. We have a 1-to-1 ratio between silicon dioxide and C2. Now it's a C1-to-2 ratio. So that's the only reason. It's just a little convenient for me to do the calculations. When this is C2, the molar mass is 24. Silicon dioxide, silicon is 28. 2 oxygen is 32. So in total it's 60. So really I need the mass of silicon dioxide over the molar mass 60. Alright? Versus another number which is going to be the number of moles of carbon, 101.8 divided by 24. So again, I was viewing 2 carbon as C2 hypothetically, so I need to just compare these two. Whichever is larger, that's in excess. Whichever is smaller, that's the limiting reactant. Alright, but Wolfram alpha seems I don't know if you can do this. Alright, yes, you can compare this two. So this number is 4.2, this number is 2.8. No, this number is 2.8, this number is 4.2. Alright, so somehow mastering chemistry is not really giving me a proper answer about comparing these two numbers. But anyway, you can tell this number is less than 3 for sure, because 180 over 60 is 3, and this is smaller than 180. And this number is definitely greater than 4, because 24 times 4 is 96. So this is smaller than 3, this is larger than 4, then the limiting reactant is this one. Why didn't I include this kilo here in the comparison? Because we have a kilo here, another kilo here. So, and we are comparing, relatively which one is larger, which one is smaller. So I'm going to just use this. Alright, and now I'm going to take care of the kilo. That will give me the number of moles of silicon dioxide. So we have 2,875 moles of silicon dioxide. And this is the limiting reactant. That means we can produce 2,875 moles of silicon. And then silicon has a molar mass of 28, so we got this number. We're gonna get 80,500 grams of silicon, or 80.5 kilograms. Alright, so this is the limiting reactant. And if you don't want to do any calculation and just try your luck, pick the one that's more expensive. The more expensive reactant is usually the limiting reactant. Determine the theoretical yield for this. How many kilograms? 80.5. We just compute it and submit. Submit. Review your calculations and make sure you round to 4 sig figures. Oh, that's interesting. 4 sig figures. Yeah, it's I think it's mainly because when I look at the molar mass of silicon, I used 28. It's 28.09, and then plus 32, and over here I need 28.09. That way I can get 4 sig figures. Now I have 80,637 grams, so it's going to be 80.64. All right, 80.64. Submit. All right, 80.63. Okay, it's right here. Again, I apologize for not including these 2 decimal places in my calculation. All right, I thought they were not important. 28 versus 28.09, but it turns out there's a small difference over here. I got 28.5 before, now it's 28.6. all right. And here's mastering chemistry calculation, the amount of silicon oxide in kilograms. All right, and we convert grams to moles, and we convert the moles of silicon oxide to the moles of silicon, and then from the moles of silicon to the mass of silicon. So you have this. Let's see. Oh, they didn't even use 28.09. They used 28.085 gram per mole as the molar mass for silicon. That's interesting. The percentage. Wow, this is really easy. So you have the actual yield 75.0, and then divided by the theoretical yield, which is 80.63. We do need to multiply this by 100 to get the percentage. Alright, 93.0%.